Okay, so let's go on to the how we might assess the certainty of the evidence. I'm just going to click on that field and you'll see all of the grade domains listed for you. So risk of bias, inconsistency, indirectness, imprecision, and publication bias. These ones are the ones for randomized control trials that we most often will use. And the ones that we typically use for non-randomized studies have already been indicated as not being part of that decision. So there's already an answer for no for those ones. And that's just because we already entered in that it's randomized control trials that we're looking at. But if it turns out in the very, very rare situation where you might be using a large effect for randomized control trials, you can change that. But for now, most often you don't need to. You wouldn't be using that. Okay, so let's get into our grade assessment. We're just going to do a sort of a mini grade assessment to show you. I'm going to flip back to a slide so that where we have all of the information from our forest plot. Let's make sure I can get there okay. So if we were doing our grade assessment, we would have the forest plot in front of us. We would also have the rest of the review available to us, and we would have our risk of bias assessment available. The risk of bias, when we're looking at risk of bias in general, we would have already have assessed each individual study risk of bias, and the green indicates that there's low risk of bias. The orange is some concern with that domain for risk of bias, and we have red dots for high risk of bias. If we just step back, it looks like we're doing pretty good, except we do have some concern with some of the domains. In particular, we have some concern with randomization here for 2 of the studies. And we did have some issues and some concern with outcome measurement for risk of bias. All of the other domains were low risk of bias. When we need to assess the risk of bias, we consider the individual studies. We will consider also the domain. Most times the domain of randomization is quite important. And I'll just say that if we looked back to the risk of bias assessment, there were some issues with allocation concealment, and we had some concern with that. So we're looking at individual studies, we're looking at the domain, that's the issue, and we will also look at the weight of those studies. If we look here, I guess if you looked at this and you looked across, you would say, actually, it seems like most of the studies are providing similar weight to the analysis. And so that would mean that when we're doing our risk of bias assessment, we're thinking that all of these are contributing equal weight to how much concern we might have. In this case, our group had decided when we looked at this that we had a little bit of concern about the randomization process and outcome measurement, but it wasn't enough concern to actually rate down by a full point for risk of bias. So that was our decision here. So basically, how are we going to handle that in GRADEpro? Well, we decided that we were going to say not serious concern, but we probably should put a note there for readers. And so what I'll do is I'll just right-click on that, put an explanation, and say some concern with allocation concealment in randomization and outcome measurement, but not rated down for risk of bias, and save that, just so that if someone sees that there were some concerns, we saw it, but we didn't rate it down. Again, just in case you do need some more information about risk of bias, you can always click on the eyes, and that will provide a little bit more information about how to assess risk of bias. So you always have that information available to you. I'll move on to inconsistency, and we'll go back to the slide. And just have a look at that forest plot. And I'm hoping people can see that okay. If we were to look at inconsistency very briefly, we might see that just eyeballing this, that there looks like there might be some inconsistency about this around this pooled analysis that we did. We'll also see from our statistical analysis of heterogeneity that we have some indications that there is heterogeneity across these studies. We might focus on the I-square, which is quite high, 72%. We have our chi-square is showing a significant value, less than, a 0.1 or cutoff. Tau, although we have a little bit more information about how we should be interpreting that. But in general, we're seeing some inconsistency, which is actually resulting in a bit of a wide confidence interval here. So because we have such inconsistency, we've actually increased the width of the confidence interval. So for me, in our group, we decided that there was inconsistency. So we clicked on serious inconsistency. Again, we'll want to put a footnote for that. We'll add a new one and just write that there was visual inconsistency and statistical analyses also showing heterogeneity. And I'll just save that. That's inconsistency. Indirectness is quite tricky because we would have to look at all of the individual studies, remembering that inconsistency is about whether our evidence directly answers our question. I won't have us go into the studies here, but let's just say that it's not serious. I'll skip to publication bias. Also, again, you would have to look at how comprehensive your search strategy was, whether you looked at individual registers for trials to see if those trials were published. You might be able to do a statistical analysis if you had more than 10 studies. But in this case, I'm going to choose that I didn't strongly suspect publication bias, but was undetected. I did a comprehensive search. I did look in the trial registries and everything was published. So let's move on to imprecision. We're going to do a little brief imprecision here. And I'll go back to the slide. Imprecision, basically, we are interested in how many people or events are in those studies, and we're also interested in how wide our confidence interval is. If we look at and see our rules of thumbs for imprecision, generally we say we need to have for a dichotomous outcome more than 300 events. And in this case, we do. But our confidence intervals are still quite wide. And how do we know that our confidence intervals are wide? Well, it's better to look at the actual effect, the absolute effect, and how wide those absolute effects are. And we can pull that right from the summary findings table in GRADEpro. We have 25 per 100 with a baseline risk with the placebo, and the risk with probiotics is 18 per 100. And that confidence interval goes from 12 to 27. If we just do a straight subtraction, it looks like we would have 7 fewer people, so 25 and subtract the 18, with an infection. But the confidence intervals, we would have 25 subtract 12, which is 13 fewer. But actually 25 subtract 27 actually means that there would be 2 more people. And if we put some thresholds about what we think is important, what's an important reduction, we would say that if we saw at least 5 people not have an infection, that this would be a slight benefit. We could actually say, it's a benefit, a moderate benefit, if 10 fewer people had an infection. And if we plot where our confidence interval and our point estimate is, we actually see that this confidence interval is including the possibility of no effect or slight benefit, and the possibility of a moderate benefit or a benefit. And to us, that's quite wide. We would say that this is a very wide confidence interval. The issue is, though, we can see from, and I'll flip back, that we do have a lot of people and a lot of events. And actually, likely, our confidence interval is so wide because of that heterogeneity. And so I don't necessarily want to rate down for imprecision because of that wide confidence interval. I actually think that it's because of the heterogeneity that we have this wide confidence interval. So when I go back to GRADEpro, I'm going to put not serious for imprecision. And if I wanted to, I could actually put an exclamation in here saying, wide confidence interval, likely due to heterogeneity. And just save that. Now I've done my grade assessment. I'm going to apply it. And type to this way, so certain defined study design, I have my randomized control trial. That's fine. Let's just make sure that there, and there we go. So we have a moderate certainty, and we now have the footnotes available. The other nice thing about this table is, again, this what happens here. And this was purposely put into the table because we saw that people needed a narrative way of understanding what the results are. So basically, if I click on this, we've tried to automate the statements, and we've come up with some standard statements, did some research on that. This 7 fewer, if you recall from our presentation, that 7 fewer is landing right in the slight benefit area. So, and that's a small benefit. So I'm going to go back to here. The size of the effect is small, but important. And it's given me choices for what to write. And these choices are based on my moderate certainty evidence. You'll notice that these statements are worded as likely reduces or probably reduces. And that's because it's moderate certainty. And you have the opportunity to decide which statement, likely, probably, and whether you use reduces a number or reduces the probably reduces or likely results in a slight reduction. So we're using the term slight all here, and we're using the terms either likely or probably. I'm just going to choose the first one. I'm going to insert it into there. And now I have a narrative way of describing the conclusions. Now I might just open it up for any key questions that I really should answer before I move on to the continuous outcomes.
We have questions and answers already provided in the chat by our shadow experts, and I'll come to these a bit later, but perhaps the question for you, is there a cutoff when looking at the I-square for choosing serious versus very serious for the certainty?
Yeah, and great question. And I think in the Cochrane handbook, and correct me if I'm wrong, we used to have some cutoffs. So we would say substantial heterogeneity was if it was greater than 70% or something. I think right now the feeling is we're not going to stick with these cutoffs. I think in general, people start to be a little bit more concerned when it's greater than 50%. But I would caution about the heterogeneity because heterogeneity is also dependent on what you think might be important. So if I do go back, if we actually thought that a slight benefit was here, this confidence interval, this heterogeneity that we thought we had actually is not heterogeneous anymore. It's all telling us that there's no effect. It doesn't even go into a slight benefit. So just be careful, just because there's heterogeneity by a number of 50 or 70%, is that heterogeneity actually important or not? So just be cautious about that.
Okay, and just a quick question. The slides of the risk of bias you keep referring, are they coming from your meta-analysis?
This here?
I suppose, yes.
I mean, this would have been our assessment of each individual study.
Mm-hmm.
And actually, there are some other softwares that do create these
Traffic lights.
yes, exactly. There are multiple pieces of software that can do that for you. And Dario, if you have access to some of that, even the risk bias tool website.
Oh, risk, yeah, okay. I
Yeah.
will provide that. Okay, so you can move on.
Great. Okay, so let's look at the continuous outcome. Continuous outcomes, you'll see here that we entered in the mean difference that came in. And this mean difference actually is about days. This is the duration of an episode of an infection. One of the important things is to indicate what that continuous outcome represents. If it's weight, you would put in kilograms here. If it's height, centimeters. If it's quality of life, you probably won't have a unit. But if you do have a unit, it's super helpful for readers to see that what it is actually. So we'll put this here. What I'll also do though is when I'm describing my outcome here, this is the mean duration of an episode of an upper respiratory tract. I might say mean number of days of infection, just to make that a little bit more clear to people. And I would say, it's not necessarily measured with anything, but if you were doing quality of life, I would enter right here SF36, whatever scale it was that was used. Again, I could enter in the length of follow-up. Maybe it's a range of 6 to 12 months again. Ooh. And I can put that in. And for us, there is no range of possible scores. But again, if you were doing an SF36, that was a VAS scale, I would put 0 to 100 or 0 to 10, because the only way someone can interpret these numbers is if they actually know what the scale is. Because a 2-point difference on a scale of 0 to 100 is very different from a scale of 0 to 10. So important to fill this in if you do have that information. But we're dealing with days, so I'm going to put that there. So right now I have a little bit more information. The other thing I still need to fill in, though, that didn't come from RevMan was, what is the baseline number of days? What I'll do is I'll go into RevMan, and let's go into that outcome let's make sure we can get there. In the analysis, I'm going to go into the mean duration here. And what I want to do is actually look at the forest plot to see what is the mean duration. And I can look at these numbers right here. When someone is not taking probiotics, the mean number of days is probably a combination of 7.9 and 8.4. That's the no probiotics number of days that someone has an infection. So I'm going to enter 8. I'm going to put in 8 days. That's the baseline number of days. And I'm just going to put a mean, and I'm going to put 8. Ooh, and apply that. So now I have that in. I have that in. I, again, need to enter in the number of the type of study design and apply that. And again, I would go through my risk of bias assessment. I'm not going to do that, but I will, just for the heck of it, show you what happens when I do. I'm going to end up with low certainty evidence because I rated down twice for imprecision. This is just an example to show you. And now when I do this, if I say that 0.21 days is no effect or a small effect but not important, I will be given different wording and make that choice. Now it's showing little to no difference, may not reduce, because 0.21 days for me was nothing. So I'm just going to choose that and apply and fill that in. So basically, continuous outcomes, little bit less to do or worry about, but important to put in details about the scale. And you have to manually enter the number of days for the baseline risk, or the score for baseline risk on a quality of life scale. Okay. The other thing I'm going to show you is, what if you had an outcome where you weren't able to do a statistical analysis? Well, you were only able to do a narrative synthesis. You couldn't pool it statistically. We're going to save that. And we're going to enter, say, for example, number of days missed from school. That's my outcome. I wasn't able to measure that statistically. Again, a mean follow-up might have been 9 months. Fill that in. And I took it from randomized control trials. I just couldn't pool them from 2 studies. And I would actually total the number of people in those studies, because readers want to know that. I can still enter in the number of people from those studies. So that's great. And here I could click on the field and then just enter in that studies found a reduction, maybe I'll say a small reduction in number of days. So I'm really just filling that in and apply it. And I still have to assess the certainty of evidence. I would go through that whole process, and I would still come up with a statement at the end. So here's an outcome. We didn't have data in a statistical analysis, but I still have it there. We would finish this whole table here. And as I was doing that, it was automatically syncing with what's happening in RevMan. So I'm going to go back to the table here. And you can see that I have my table under now in the summary findings table. I'm going to open that up, and it was automatically syncing with my table in RevMan. There it is. If it happens that I need to change something or something doesn't look good, I'm still in GRADEpro. I could make the change, and it will automatically sync with what's in my RevMan review. So that's doing it itself. And I typically make my changes in GRADEpro.
A quick question, beginner's question. Can you use GRADE on just one study?
Oh, absolutely. So whatever evidence you have for an outcome, if it's 5 studies, 10 studies, 100 studies, or just one study, that's the evidence you have, and you need to assess that. You need to do a GRADE assessment. You need to tell people how sure you are about that study. What if that study is a multi-centered study, massive 10,000 people? You need to tell people how certain you are about that result versus a single study that has 10 people in it. How certain are you about those results? So absolutely.
And how do you assess heterogeneity in a one study evidence base?
If it's one study, there's no heterogeneity. So you just mark no concern.